Hello everyone, myself Abhijit Mahata. I have completed my master degree from Ramakrishna Mission Vivekananda University, which is a very reputed university in India. Right now I am doing PhD on pure math, especially topology and algebra. I have 5 year online teaching experience. I taught many students from US, UK, Hong Kong and many other countries. I taught them pre-calculus, calculus, linear algebra, abstract algebra, real analysis, complex analysis, differential equation, and many more subjects. Today, I am going to explain here what is a complex number, what is magnitude of a complex number, what is argument of a complex number, and what is polar form of a complex number. So let's start. So first, let me define complex number. So here it is. First, I will define everything and then I'll give example for every concept. So a number of the form, a number of the form G equals to A plus IB, where AB are real. AB are the real numbers and I equal to square root of -1 is called a complex number. So for example, we can take G equals to 2 plus 3i. It is a complex number. G equals to, we can take negative 2 over 3 plus 1 over 2i. We can take G equals to pi is a real number plus 3i. So we can define many actually complex number this way. So here observe that if we take any complex number G equals to a plus ib, then we can think that complex number will have two components, this a and coefficients of I. So this a is called real part of G and this b we called the imaginary part because it is coefficients of I and I is square root of -1. And why it is imaginary? Because we cannot calculate square root of negative number in real number system. So it is therefore the imaginary. We call it is imaginary. So that's why B we call the imaginary part. So any complex number will have two parts. One real part, other complex imaginary part. Now we see the geometrical meaning of complex number. So here it is. So let me write down here. So geometrical meaning of complex number. Since we know any real number, we can geometrically represent it as a length. How? So if you consider the real line and if I give you a real number, let's say here you have 0 and here if I give you a real number r, then if it is r positive, then you take to the right side of origin. So this length is r, then this point will represent the r. If r is negative, then it will represent to the left hand side of origin. So this we move to the left side, absolute value of r length, like that. So similarly, complex number we can represent as a point on plane. How? So if we take any point, let's say G equals to any complex number a plus ib, then we can identify that complex number with the point a comma b. By this identification, we can represent any complex number as a point on xy plane. So if you take x-axis and y-axis, then the point, say here we get a point having coordinate a comma b. That point, let's say we denote by p suffix g. P suffix g mean we indicate that this p point actually corresponding to the complex number g. So if you take any complex number, it will be a point on the xy plane. For example, if you take, let's say, g equals to -2, -3i, then you can identify this with the point -2 comma -3. So -2 means this side you move and then downward 3 units. So here you get the point -2 comma -3. So this point will represent the complex number g equals to -2 -3i. So the same argument will true for any complex number. So in general, if you take z equal to a plus ib, then that you can identify with the point a comma b, then you get a point on the xy plane that we denote by p suffix g. Now what we can do, we can join o to the point p suffix g. So like that. Now this will make, this ray o to p will make some angle with positive x-axis. So that angle we can take two different way, either anti-clockwise, then in this case we get the positive angle. So in this case theta if you call, then in this case theta will be positive. Now if we take this way, then the theta we will get, it will be negative value. So any one of, either clockwise or anti-clockwise, any one of the value of theta we will consider and call it as the argument, as a argument of the complex number g, that we see how to calculate. Also the distance of that complex number a plus ib from the origin, we denote it by r, called the magnitude. So clearly you can complete a, here we can complete a right angle triangle. So then this will be a and this will be b. So a also given by r cosine theta and this is given by r sine theta. So what is the significance of r? R is the magnitude, it is denoted by magnitude of this, and theta we denoted by argument of g. So how we calculate? So basically we have a relation, we can see here that a equals to r cosine theta and y equal to sorry, b equals to r sine theta. So this is the relation from where we can calculate. AB will provide us, then we have to calculate r and theta. So we can do it basically. Now see, if we make square both sides, then what should we get? We get here a square plus b square. So basically we get r square and here cosine square theta plus sine square theta. So what should we get? So let me write in, in the next. So we'll get r square equal to a square plus b square. So then we have r equal to square root of a square plus b square. I'm assuming here r is positive and some people actually use r negative. In that case, I am neglecting here. So I am taking r positive. So once you have r, this cosine theta will be what? A divided by r. This means square root of a square plus b square. And sine theta will be what? B divided by square root of a square plus b square. From here we can calculate, so this three, using this three we can calculate r and theta. Here one example. So example. So you have the complex number z equal to 1 minus I. So you can identify this with the point 1 comma minus 1. So in the xy plane where you have the point 1 unit positive x-axis and downward 1 unit. So you get here the point. So this point has coordinate 1 comma negative 1. So this is x and this is y and here origin. Now if we join, so let's say origin to this point I am joining. So then we will have two angles. Either we can take this direction, I mean clockwise, or we can take the anti-clockwise. Any way we can take it. So now see, so if you calculate r, so here a equals to 1 and b equals to negative 1. So r equal to square root of a square plus b square. So what should we get? We get 1 square plus minus 1 square. So square root of 2. Now cosine theta equals to what? A over r. So 1 over square root of 2. And sine theta will be what? Minus 1 over square root of 2. So this is basically cosine pi by 4 and this is minus sine of pi by 4. So look at this. This angle actually pi by 4. The value of this angle is pi by 4. Now if you want to get this angle, so how you get it? So total is 2 pi from here to here. So if you look at the total angle from here to here, the green color, so total 2 pi. Now you have this pi by 4. So from here to here, this measure will be 2 pi minus pi by 4. So this will be cosine 2 pi minus pi by 4. So this will be also sine of 2 pi minus pi by 4. So this is cosine of 7 pi by 4. And this is sine of 7 pi by 4. So we are getting theta equal to 7 pi divided by 4. So this is an argument. So now some people also can take this angle, since you are taking the clockwise, so negative pi by 4 also will be argument. So polar form is what? Basically polar form is given by g equals to r means square root of 2 bracket cosine of theta 7 pi by 4 plus I sine of 7 pi by 4. So we have seen here how to write down the polar form of a complex number, and the polar form has many applications in complex number system. So one example you can say, we can calculate nth root of any complex number using the polar form. Yes, so therefore it is very important concept. We have to learn, everyone, the polar form of a complex number, how to write down. Thank you so much. Bye.